This is 10.7 of geometry. So we're talking about area or circles still, and now we're going to talk about the area of a circle. So the area of the circle is pi r squared. We don't have one for diameter, you have to use radius. Suppose we could come up with one for diameter, but it'd be a little messier. So A equals pi r squared. Alrighty, so what is the area of a circular wrestling region with a 42-foot diameter? So if our diameter is 42 feet, right, that goes all the way across. A radius just goes halfway. So if we divide that by 2, we get that our radius is 21 feet. Right, our diameter was 42, divided by 2 we get our radius, and that's 21 feet. And now we can plug that into our area equation. A is equal to pi r squared. So A is equal to pi times 21 squared. They don't specify that they need it in terms of pi. So I'm just going to multiply that out. So pi times 21 squared gives us about 1,385.4 feet squared. Okay, a sector of a circle, pictured here, uses 2 radii and an arc to bound it off, okay? Kind of like a sliced pizza, that's what we're looking at here. And we can figure out the area of a sector of a circle, just like we did when we were looking for the length of an arc, right? If we know the portion of the circle we're looking for, and this time if we calculate the area, then we can find the area of the sector. So it's the arc measure over 360 times the area, so pi r squared. So let's do our got it problem here. It says a circle has a radius of 4 inches and it has a 45-degree minor arc. So this is also 45 in here. It's 45 on the outside too, right? And they want us to leave our answer in terms of pi if we could find the area of the sector. So everything in here. So we put our angle measure, 45 over 360 times, and then we need to find the area, so pi r squared. So this is 45 over 360 times pi times 16. So I want pi in my answer, so I'm going to do the 45 divided by 360 times the 16, which gives us 2. So this is 2 pi inches squared. Okay, so now we're going to talk about a segment of a circle, kind of like the crust of pizza maybe. So the segment of a circle, you can see a picture of it there. It's bounded by an arc and segments joining its endpoints, okay? If you look down here, the area of the segment, you can see, is when we take the area of the sector and we subtract this triangle, right? These are both radii. And we get the area of the segment. So we're just going to do this for acute triangles because we're going to do it a little differently than the book did. We're going to use the 1/2 BC sine of A if we need to, right? This got it problem uses a right angle, so it's a right triangle. So then we can use our regular equation, 1/2 base times height. We'll do one with that other problem in a second. So to figure this out, we need to do the area of the segment minus the area of the triangle, right? So it's going to be segment minus the triangle. So the area of the segment, we do the angle measure, so 90 over 360 times pi, and our radius is 4 meters, so 4 squared, right? So that's 90 over 360 times pi times 16. And I'm not going to leave that in terms of pi. I'm just going to multiply that out. That gives us 12.6 in meters squared, right? And then our triangle, if it helps, draw it out to the side maybe. So I'm going to right side it up. 4, and it's a 90-degree angle, right? So in this case, we can do A equals 1/2 base times height. So that's 1/2 times 4 times 4, which gives us 8 meters squared. And then we need to subtract them. So we do 12.6 minus 8, which gives us 4.6 meters squared. So the area of that sector is 4.6 meters squared. I want to show you one other one. Let's say we have a circle that doesn't have a right triangle, okay? Let's say it has an angle of 50 degrees. Okay, and let's say the radius is 6. Okay, if we want to find the area of that segment, we're going to find the area of the sector. Oh, whoops, I messed that up down here. This is the sector, right? Sector minus the triangle gives us our segment. So first I got to find the area of my sector. So I'm going to do 50 over 360 times pi, and our r is 6, so 6 squared. So that's 50 over 360 times pi times 36. Again, I'm not going to leave it in terms of pi. So 50 divided by 360 times pi times 36, which gives us 15.7. Oh, let's put this in inches. So inches squared. So that's the area of my sector. Now I need to find the area of that triangle, and I can subtract them to find the area of my segment. So that triangle, this is a radii here. So that's 6. So this is also 6 over here because that's also a radii or a radius. So I'm going to use A equals 1/2 BC sine of A. Okay? So the area is equal to 1/2 times 6 times 6 times the sine of 50, which on my calculator, 0.5 times 6 times 6 times the sine of 50 gives me 13.8 inches squared. And now to find the area of my segment, I'm going to do the sector, 15.7 minus 13.8, that triangle, which gives me 1.9 inches squared. And there's your homework.